Hi guys, this is Mrs. Homer, and today we're going to look at test crosses. So a test cross is when you have an unknown dominant and you cross it with an organism to help you determine its genotype. So here's an issue. Let's say you have a black Dalmatian, so it has black spots, which is dominant, big A, or it could be big A, little a because it's dominant. And the liver spotted is the recessive color, little a. And you want to buy a dog that is homozygous black spots, not heterozygous, because you don't want to pass on that little a allele in the future to your puppies. So we have to do something to help us figure out the genotype of a black dog. So when you get that black spotted dog, you don't know, is it big A, or is it big A, little a? You just don't know, unless you maybe know the genotype of the parents. And so you can do what we call a test cross, which means you'll mate your dog with some dog in order to determine what its genotype is. Now, you could mate your dog with a big A that's known, a big A, or a little a. So you want to pick one of these genotypes to mate your dog with, this unknown dominant, to help you determine what its genotype is. And so a test cross, if you want the best chance at determining what your genotype of your unknown dominant dog is, you would test cross it with a little a recessive dog. Not the big A, not the big A, little a, but a recessive dog. So why do we test cross with a recessive dog instead of the other two? Well, if you check out these Punnett squares, here on the top are the genotypes of my potential dog. It could be big A, or it could be big A, little a. Now, if I cross with this little a, and my dog is homozygous dominant, then 100% of my puppies are going to be dominant. However, if my dog is heterozygous, then when they have puppies, only 50% are dominant and 50% are recessive. So there's a big difference in the offspring of these crosses, which would help me determine the genotype of my parent. So as soon as I cross my parent with this recessive offspring, this recessive parent, then the offspring will help me determine the genotype of my parent. So check this out. This is an example of a test cross. So this is an unknown black sheep. So it's got big B, or it could be big B, little b. And again, I'm going to cross this with a little b. That's the recessive. We always do a test cross with the recessive because it's going to be the highest chance of helping us determine the genotype of our parent. So let's take a look at the offspring. Looking at the offspring will tell you the genotype of your parent, the unknown dominant. So if all the offspring are black, they're all dominant, then your parent was probably big B, and passed on that big B allele. But if you have any recessive offspring, then you had a heterozygous parent that passed on that little b to that white recessive offspring. So again, we always want to do a test cross with that recessive organism. And when we do a test cross with the recessive organism, if we get all dominant, then we probably had homozygous dominant, big B. If we get some or any or even just one recessive, then that absolutely 100% determines that your parent was big B, little b. And by doing a test cross with the recessive organism, it gives us the highest chance, a 50% chance of seeing that white offspring. So it gives us the best chance of seeing the recessive. So this is the best cross to do in this circumstance. Now you do some practice problems to figure this out for yourself. So we have a black cat, and black fur is dominant to white fur. What genotype should you cross your black cat? Remember, you don't know the genotype of your black cat. Is it big B, or is it big B, little b? Which genotype should you cross your cat with to determine the genotype? And the answer, little b, little b. Always cross with the recessive, and that will give you the highest chance of knowing what the genotype of your parent is. So now let's look at the offspring. Let's say we have 10 kittens and 8 are black and 2 are white. What does that tell me about the genotype of my parent in this test cross? It tells me that my genotype must have been big B, little b. So my cat must have been big B, little b because it passed on that little b to those white kittens. If instead all 10 of the kittens were black, what would that tell me about the genotype of my cat? It would tell me that it was big B because it passed on the big B to all of the kittens. Now you might ask, why do we always cross with the recessive? Well, we want a big difference between the two possible Punnett squares. So if I crossed it with instead a homozygous dominant organism, all of the puppies, all of the offspring, no matter what they are, would all be dominant. And so that wouldn't really tell me anything. If I crossed it with a heterozygous organism instead of that recessive organism, then I only get a 25% chance, which is not a very big difference between the two Punnett squares. So we always want to go with the recessive organism in a test cross because that gives us that 50% chance of seeing that recessive come out and seeing a difference, knowing whether it's the homozygous dominant big B or the heterozygous big B little b as our parent. So always cross your unknown dominant with the recessive organism in a test cross. Now, if you haven't figured it out yet, you don't do a test cross for a recessive organism because if you have a recessive organism, you already know its genotype. You don't have to do a test cross. All right, that's all on test crosses. Let me know if you have any questions.